Explorer 1, NASA's farthest journeying rocket, proceeds with its astounding endeavor through space, perfectly imparting huge data from the most profound region of the universe. For very nearly 50 years, this amazing space test has changed how we might interpret space. Anyway, actually, the Space Mechanical Assembly has been conveying upsetting data back to Earth, leaving the whole space industry in shock. Are these upsetting signs the consequence of a specialized breakdown or the exercises of extraterrestrials? Go along with us as we reveal the truth behind these staggering transmissions. Since the dawn of mankind, specialists have been enchanted by the mysteries that lie past our sublime limits. This interest incited the memorable send-off of the Pilgrim 1 and Pilgrim 2 transports among other brilliant space missions. These earth-shattering missions, which had been talked about for a long while, started with the send-off of Adventurer 2 from NASA's Kennedy Space Focus on August 21, 1977. 14 days after the fact, on September 5 of that very year, Voyager 1 followed suit. These twin tests, each gauging a critical 720 kilograms, equivalent to a small vehicle, were pushed into space during a unique arrangement of the outer planets. All through their amazing odyssey, these bold explorers explored various bearings and velocities, driving to a vital second on December 15, 1977, when Explorer 1 outperformed its indistinguishable twin because of varieties in their ways. From that point forward, Voyager 1 has turned into a critical resource, giving us a wealth of data and unraveling space-related mysteries. Before we dig into Voyager 1's surprising new disclosure that dazed the entire space industry, how about we investigate the excellent pictures caught by the rocket during its crucial Jovian imaging mission in 1978. Voyager 1 was situated about 265 million kilometers from Earth. From this vantage point, it imparted a shocking number of photographs back to Earth. In January 1979, it set out on an uncommon 100-hour try capturing a hypnotizing time-pass film showing 10 revolutions of Jupiter. A cornucopia of 3,750 pictures permitted us to notice Jupiter's sublime dance in distinctive detail. In the resulting months, Pilgrim 1 meandered through the Jovian moon framework, making a striking disclosure: the presence of a little ring encompassing Jupiter and 2 new moons, which further extended how we might interpret Jupiter's interesting area. To guarantee safe entry and forestall a likely effect with Titan, one of Saturn's moons, restorative moves were executed. Pilgrim 1 proceeded with its heavenly journey around Saturn, uncovering 4 extra moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the finish of the Saturn mission, researchers decided to close the Pioneer planetary mission, pushing both Adventurer 1 and Wayfarer 2 past the limits of our planetary gathering. Jumping through space at a shocking pace of 325 million kilometers every year, in January 1990, another section started, the Pioneer interstellar mission. During this stage, Pioneer 1 conveyed some of the most popular photographs in history, deifying the Sun and the greater part of the planets. One individual who played a vital role in broadening the missions beyond their underlying targets was the unmistakable cosmologist Dr. Vasily Sands. As a part of the Voyager mission's imaging group, Dr. Sands enthusiastically pushed for catching one last arrangement of pictures as a farewell gift to humanity. Against all chances, his resolute determination bore fruit on February 14, 1990, when Pioneer 1, situated 6 billion kilometers from the Sun, set out on a visual journey well known as the Planetary Group Family Picture. These staggering pictures, adding up to 60, added to the transport's striking assortment of 670 photographs during its adventure with Neptune. Explorer 2 accomplished an unprecedented achievement by recording wind speeds surpassing 13,100 meters per second, making it the fastest wind of all time recorded within our local planetary group. As the rocket wandered within 280 million kilometers of Neptune's blue, methane-rich air, it furnished us with noteworthy bits of knowledge into this far-off heavenly body. Neptune's largest moon, Triton, was uncovered as one of the coldest inhabitants within our planetary group, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's exceptional elements, such as its nitrogen gas-heaving ice volcanoes that pushed frosty particles 5 miles into its amorphous climate, also enthralled our imagination. These excellent revelations expanded our perception of the immense assortment and intricacy of heavenly objects residing in the farthest reaches of our local planetary group. Don't go anywhere. The Voyager 1 rocket has as of late made quite possibly of its most alarming disclosures. Yet first, we should figure out what it has accomplished in the most recent 45 years. The achievements of the Traveler twin tests have been nothing shy of remarkable. More than 4 decades prior, their underlying perceptions of Jupiter and Saturn's moons left researchers in wonder and broke past presumptions about these far-off universes. These moons, once accepted to be lethargic and intensely scarred like our own moon, ended up being abounding with topographical movement. Wayfarer 2, specifically, accomplished several excellent accomplishments during its journey. It left a mark on the world in 1986 by turning into the first transport to fly by Uranus. Only 3 years later, it accomplished another striking accomplishment with a flyby of Neptune. Up to the current day, it stays the sole rocket to have wandered on such a way. As the Voyager rockets proceeded with their journey, NASA executed different measures to broaden their operational life expectancy over later years. Unnecessary parts and heaters have been deactivated to preserve energy, ensuring that these gallant wayfarers can proceed with their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and architects who have been engaged with this amazing undertaking from the very beginning, the zenith of the Voyager missions is both a snapshot of pride and a hint of sadness. Their steadfast commitment and enthusiastic endeavors have far outperformed their underlying assumptions. The wealth of information returned by the Voyagers has given significant bits of knowledge, fueled various logical revelations, and touched off the creative mind of innumerable analysts and space lovers. Pioneer 1 and Wayfarer 2 were no ordinary space tests. They were meticulously designed as stable platforms, with a turn rate north of 15 times slower than the hour hand of a clock. This design decision minimized visual blurring as the rocket captured pictures and information while traveling through the infinity of space. Indeed, even before their experiences with the outer planets, their noteworthy imaging capabilities began to dumbfound researchers and the public alike. The space apparatus began communicating pictures of Jupiter before arriving at the gas giant. These early pictures, showing the swirling mists and iconic Great Red Spot, pleased crowds at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, somewhat larger than Earth's moon, ended up being the most volcanically active body in our solar system. The shuttle's instruments identified spectral signs from Io, which were confirmed by the clear pictures they captured. Towering volcanic plumes and a surface scarred by volcanic eruptions were revealed. One of Io's most unmistakable volcanoes erupted with a power multiple times greater than Mt. St. Helens, covering an area practically the size of France. While the space apparatus cameras were ultimately shut down to preserve power and memory before their excursion into interstellar space, it is essential that the photos they captured did not include Mercury and Mars for different reasons. Aside from the Voyager 1 and Voyager 2 interstellar tests, NASA has likewise worked other unmistakable shuttle like Adventurer 10, Explorer 11, and New Horizons. Pioneer 1 passed by Explorer 10 on February 17, 1998, denoting the event when Explorer 10 turned into the most far-off shuttle. Adventurer 1 proceeded with its single process for an additional 14 years before finally entering the interstellar atmosphere on August 25, 2012. Although there could have been no other space tests in sight to observe, NASA didn't freely report this striking accomplishment until 2013. What methods ensured the progress of the Wayfarer missions? One method stood out as particularly brilliant: gravity assist moves. These moves played an essential role in propelling Voyager 1 and Voyager 2 on their daring mission to explore the outer reach of our local planet group. To come to these far-off objects and gather valuable data, the shuttle required more than just their own drive systems. They required a boost, and gravity assists provided just that. Imagine Voyager 1 and Voyager 2 setting out on their grand tour through the local planetary group. Rather than depending entirely on their engines, they engaged in a celestial dance with some of our local planet's heavyweights. These planets formed clusters that performed an incredible dance using the immense gravitational pull of these giants to slingshot themselves on their way. This technique allowed them to save valuable fuel and gain the necessary speed to visit different objects. Delving into the basics of gravity assist, moreover known as a gravitational slingshot, we see that the idea behind this move is to transfer some of a planet's energy to the rocket as it sails by. Imagine Pioneer 1 approaching Jupiter, a massive gas giant with a matching gravitational pull. With meticulous precision, Pioneer 1 came around Jupiter at the perfect angle and speed. Jupiter's gravity pulled at the rocket, accelerating it to a higher speed and giving it a significant boost. Performing a gravity assist move requires outstanding accuracy. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a shocking deviation from its intended course. The level of precision required is daunting. However, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Voyager spacecraft on an astonishing journey through the local planetary group. Pioneer 2, for example, used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These heavenly moves were of vital importance in making the Grand Tour possible. The Pioneer missions owe much of their success to these gravity assist moves. Wayfarer 1 continued to reach interstellar space, with Wayfarer 2 quickly following suit, all thanks to the accuracy of these moves. The concept behind gravity assist is simple, but the execution is quite complicated. Wayfarer 2's Grand Tour required a level of accuracy where missing any of these slingshots could have resulted in a failed mission. However, the dedicated individuals behind these missions were determined and steady in their quest for information. While gravity assist played a critical role in exploring the universe, another critical aspect ensured the progress of the Pioneer missions. The Deep Space Network, DSN, often considered the interstellar telephone line that kept us connected to our brave Pioneer tests as they ventured into the great unknown. The DSN, less showy than a space apparatus, is equally vital. The Deep Space Network is an arrangement of enormous radio antennas, precisely situated around the world, including locations in California, Spain, and Australia. These massive dishes, ranging from 26 to an incredible 70 meters in diameter, act as gigantic speakers, working with communication with shuttle going beyond our planet. The Adventure tests, equipped with cameras, sensors, and instruments, served as our eyes and ears in the infinity of space. To grasp the information they sent and to provide them with new instructions, a robust communication system was essential. That is where the DSN came into play. Imagine Explorer 1 on its way to the outer reaches of the planetary group, sending a message back to Earth as a faint signal traveling at the speed of light. As it crosses the boundless field, the signal weakens. However, the epic radio antennas of the DSN can capture that whisper. They lock onto Explorer's weak signal, working on it and transforming it into data that scientists can analyze. But the DSN doesn't just receive signals. It also sends commands. The Pioneer missions are dynamic endeavors requiring scientists and engineers to adjust directions, redirect the space apparatus, or change instruments. The commands are sent via the DSN, which broadcasts them into space to reach Explorer and guide its operations. It works as a two-way conversation among Earth and the farthest human-made objects in the universe. One striking aspect of the DSN is its robust operation. It works tirelessly 24/7, listening for those distant signals. It's like an unblinking eye on the universe, ensuring that we remain connected to our space tests even when they are billions of miles away. The Traveler mission remains a testament to the power of collaboration and innovation. While the shuttle embarked on their grand journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unexplored universe, enabling us to explore the outer planets and venture into interstellar space. Did Pioneer 1 experience a breakdown, or were outsiders included? All through its remarkable 45-year journey in space, the Explorer 1 space test has remained sound, tenaciously performing its mission. However, as of late, specialists have seen a few irregularities in performance that have ignited interest. Pioneer 1 is currently conveying curious messages back to Earth, making the feeling that it is uncertain about its exact location coordinates. What makes this discovery significantly more baffling is that the initial data received from Pioneer 1 were limitless and incomprehensible, leaving NASA researchers confounded. Upon assessment, researchers saw that the offender behind the mutilated data was the Attitude Determination and Control System, AOX, This embedded hardware is liable for measuring, reporting, and changing the space apparatus position in space. It has an antenna guided towards Earth, enabling it to send data back home. The breakdown had occurred when the software unexpectedly changed to sending its telemetry data through a faulty embedded computer that had been dormant for years. NASA engineers were able to correct this anomaly by instructing the space apparatus to resume sending data through the correct computer. Thus, uncorrupted data from Pioneer 1 is again reaching NASA. However, the question that remains unanswered is why the rocket changed to the failing computer in the first place. While NASA researchers have advanced a theory that a defective command from another onboard computer could have triggered the odd behavior, they still have yet to pinpoint the exact cause. To get to the bottom of this mystery, Susan Dodd, the project manager for the interstellar mission, stated that they plan to conduct a thorough memory readout of the rocket and fully analyze its operations. This in-depth examination aims to examine the issue that led to the telemetry problem. It is vital that, notwithstanding the erratic data transmission, the space apparatus itself seems to be working properly. None of the rocket's fault protection systems have been triggered. Thus, Pioneer 1 has not been forced into safe mode, and its signal remains of strength for parts possible. A factor adding to this inconsistency is the harsh environment of space. Astronomical radiation and extreme temperature fluctuations can pose challenges to the operation of a rocket like Pioneer 1. Cosmic radiation consists of high-energy particles originating from distant stars and galaxies. These particles can penetrate spacecraft structures, causing electrical disturbances, data signal distortions, memory errors, and data corruption. In addition, temperatures in the infinity of space can drop to bone-chilling levels or soar to scorching highs, putting immense pressure on the space apparatus components. Despite the rigorous testing and meticulous engineering that went into designing Pioneer 1 to withstand these conditions, the harsh realities of space can still take their toll over time. Another fascinating possibility that has captured the imagination of some is the idea of extraterrestrial interference. Could Pioneer 1's odd behavior be attributed to the actions of intelligent beings from beyond our local planet group? While this idea might seem more like science fiction than reality, it's not entirely outside the realm of possibility. The infinity of space and the countless exoplanets it harbors leave room for speculation about civilizations far more advanced than our own. However, before jumping to conclusions of extraterrestrial intervention, scientists are diligently examining every aspect of Voyager 1's complex behavior. Whether the rocket's oddity is due to a technical glitch, cosmic radiation, or something else altogether is not yet clear. But one thing is certain. The mysteries of space continue to intrigue and inspire us, fueling our ongoing quest for knowledge and understanding of the universe.